California Water Quality Monitoring Council. Thank you, Monica, for getting the recording started. So I'm here with my co-chairs, Dr. Monica Arienzo from the Desert Research Institute in Reno, as well as Shelley Moore from the Moore Institute for Plastic Pollution Research. And today we have a really fun agenda. But first, before we get to that, I just want to remind everyone who we are for those folks that may have not come to a previous meeting. Thank you all. This is the Microplastics Monitoring Subcommittee of the California Water Quality Monitoring Council. And we are a subcommittee that is underneath the trash work group within the California Water Quality Monitoring Council. It's been around for a number of years. Our committee is focused more on microplastics, and we are currently providing a local and global community for exchange of information and data for microplastics monitoring methods and tools. We have 3 work groups as part of our subcommittee, including the Sampling and Analysis Playbook work group that is led by Shelley. We've got a Communication Toolbox work group that was led by Brent Alsbach. That work group's product is now finished, and the work group is no longer meeting. And we also have a work group that doesn't meet very frequently, but is focused on laboratory accreditation, helping any labs that are interested or working on laboratory accreditation or are accredited, want to share information and tools, as well as talk about data analysis, mostly when it comes to monitoring. So all of our meetings are recorded and posted on YouTube. If you want to go check out previous meetings, there's a bit.ly link here. We can drop it in the chat. We've got several years of meetings here with some pretty incredible guest speakers over the years. So if you want to brush up on some information on microplastics, you can check out our archive back there. And without further ado, we'll get into today's agenda. So we will be hearing from Nick Costanza from the city of Loveland. They've been doing some really groundbreaking work out there monitoring for microplastics. It's one of the very few jurisdictions outside of California, anywhere in the world, is really taking a lead on this from a government role. So really excited to hear from Nick. And then we'll be also hearing from Dr. Valerie Hanley today from the Department of Toxic Substances Control. She's presenting on the ITRC's Microplastics Outreach Toolkit, fantastic product that has been years in the making. And then we'll hear some updates from the community, anyone that wants to share, but we'll be hearing specifically from Shelley Moore about laboratory accreditation. And then we can have an open discussion for anyone that wants to share anything or ask questions, bring anything up. So I'll pass it over to Nick.
Yeah, thanks, Scott. Let me just get set up here.
Looks good, Nick.
Okay, I can't see it on my end, but I'll just look at my PowerPoint. So good morning, everyone. My name's Nicholas Costanzo. I'm a water quality scientist with the city of Loveland in Colorado. I'd like to thank Scott and Monica first for inviting me to share with you the work that we've been doing regarding microplastic sampling throughout our water system. So we have been, hold on, technical difficulties here. There we go. So we've been working on developing and implementing a microplastic sampling plan over the past year. And this presentation is just going to highlight how we went about doing that and kind of what we learned along the way, things we're going to change in the future, and how we're going to move forward. So let's get into it. So just to start off here, I'm going to give everyone a little background information on the city of Loveland and our water treatment system. We're located in northern Colorado along the Front Range of the Rocky Mountains. We are the 15th largest city in the state with a population of around 84,000 people, and we are a combined water and wastewater utility. On the water side of things, we have a max capacity of 38 MGD with an average flow of about 18 MGD in the summer and 6 in the winter. And our wastewater plant has about a 10 MGD capacity. So The city has two primary drinking water sources, Green Ridge Glade Reservoir, which is a reservoir to 68.
Did we just lose Nick?
Looks like we've lost Nick.
Who knew?
Hopefully he'll come back.
While we're waiting, I think I've seen the sampling and analysis plan online, and I've seen it, but I can't find it today. Does anyone have a link they can share?
The sampling analysis plan for
Loveland, Colorado.
There we go. Nick's coming back in.
Yay.
Sorry about that, y'all.
Yes, sorry about that. I got kicked off there for a second.
Oh no.
Let's try this again. Okay, there we go. Okay, so as I was saying, the city, we have two drinking water sources, Green Ridge Glade Reservoir, that's a 6,800 acre-foot reservoir on the edge of town. And then we have the Big Thompson River, which runs 78 miles from the headwaters in the Rocky Mountains down to the town of Greeley, which is just a bit east of us. And there it links up with the South Platte River. So like many states in the West, we rely on collection of precipitation and snowmelt to meet our demand for water. The eastern slope of the Rocky Mountains has most of the state's population, therefore most of the demand for water, but it tends to be fairly arid when compared to the western slope. So to compensate for this, there's a tunnel and canal system that diverts the water from the western slope of the Rocky Mountains to the eastern slope where it's ultimately needed and into our two water sources. So to give you an idea of what that looks like, here we have the city of Loveland, and then you could see on the left side of the screen, there's the upper Colorado River Basin. The right side, you have the Big Thompson watershed, and splitting those is the Continental Divide. So there's that tunnel that runs from the Grand Lake area through the mountains to the Estes Park area where it comes out. Some of that water is then released into the Big Thompson River, and some of that water is then taken through some more tunnels and canals where it ultimately gets fed directly into some various reservoirs on the east slope, including Green Ridge Glade Reservoir. So I'm just going to highlight a few studies that have some significance regarding microplastic in Loveland source waters. The first study listed here was performed by USGS, and it focused on the prevalence of microplastics in the Rocky Mountain snowpack in Colorado. Their study found that atmospherically deposited microplastics in the snowpack were present all throughout the state, and that they seem to be trending upwards from the years of 2013 to 2016. Being that snowpack is a major source of water for us, this study highlights the potential for microplastic contamination throughout our sources, particularly during runoff when that snow is melting, it's entering our river, and we're pulling it up through our water treatment plant. The second study was funded by Northern Water, and Northern Water is a federal government agency who's in charge of much of the water infrastructure in northern Colorado. And the research was performed by the Inland Ocean Coalition. And this study actually did sample directly from the Big Thompson River for microplastics. And they found that concentrations were fairly low, ranging between 0.02 and 0.07 microplastics per liter. So we'll keep that in mind when we're going over the results that we got from our study. So with that, let's get into our study. As of now, there's no mandate in the state of Colorado to sample for microplastics in water. So why are we doing this anyway? As you're all probably aware, the discussion around microplastics in water systems has been gaining momentum in the public eye, and we wanted to be prepared for when we have a customer asking us how it might impact them, or for any future regulations that may be put in place regarding microplastics. So we ultimately just wanted to take a proactive approach towards it and better understand how these microplastics could be impacting our water systems. The initial round of sampling that we planned was designed to be a high-level overview to gather data so that we could have more directed sampling efforts in the future. So when we were designing our sampling plan, we decided to break it down into 3 primary areas of focus. The first area of focus was on drinking water. For this phase, we sampled our 2 raw water sources, the Big Thompson River and Green Ridge Glade Reservoir, with the idea of determining microplastic concentrations of our source waters. Then we sampled our treated water at the point of entry to the distribution system with the focus to determine how effective our treatment processes are at removing microplastics. And then finally, we sampled 2 distribution sites, one representative of the average residence time of our water and one representative of the maximum residence time of our water. And this was to determine if microplastic contamination was occurring within the distribution system, and if it was, if the concentrations were varying based on water age. So the second area of focus that we had was on the environment, and we wanted to see the effect of our water reclamation facility discharge on microplastic concentrations in the lower Big Thompson River, which is where we input our discharge into the lower Big Thompson. So for this focus area, we sampled upstream and downstream of our water reclamation facility discharge. And those samples were taken directly from the river. So the final area of focus is on water reclamation. The goals of this focus are to determine the concentration of microplastics coming into our water reclamation facility and how well the water reclamation facility is removing those microplastics. So we have not sampled for this phase yet. We put it on hold due to difficulty in finding a lab who would be willing to analyze wastewater samples within our project budget. So onto our sampling method, we opted to go the route of an inline cartridge filter opposed to the ASTM sieve method. Although there isn't a standardized method for microplastic collection using inline filtration, based on the scientific literature, we felt that this was the direction that the community is moving in. And I'm pretty sure this is something the folks over at California have been looking into as well. So we decided on the inline filtration for several reasons, but primarily it was to minimize the potential for airborne contamination while collecting samples. If there's one thing I've learned from microplastic research, it's that they are everywhere and it is very difficult to avoid contamination. So we wanted to take all the steps that we could to minimize it when possible. Some other benefits that we saw in using an inline cartridge filter were its ability to recover smaller microplastics. In our case, the filter that we used had a pore size of 5 microns, and I believe the ASTM method typically goes down to only 20 microns. And since we were going to be focusing on sampling treated drinking water, we felt it was important to prioritize that smaller detection threshold, being that we weren't expecting to see too many microplastics above the 20 micron mark in the treated water. So additionally, the use of an inline filter allowed for much quicker sampling. One sample was taking on average between 25 to 45 minutes to collect. Depending on how much particulate matter was in the water, things were getting clogged up a little bit in some instances. But compared to the ASTM method, which I think in some cases is calling for overnight sampling, it sped things up quite a bit there. And just while I'm talking about target volume, based on the information we found in the scientific literature, we decided to set those values at a minimum of 500 liters for our source water samples and 1,000 liters for our treated water samples, unless we experienced clogging before that. And on top of this, as you can imagine, the whole system was steel and brass components, and we tried to minimize plastic anywhere throughout the sampling chain when possible. So here's an image of what our setup kind of looked like. So we have this stainless steel hose that's connected to the sample tap, connected to a check valve, and then another stainless steel hose. The check valve's just there to prevent any backflow if the filter ends up clogging up. Then on both sides of the filter, we have ball valves so that once we collect our sample or after the filter is cleaned and we're traveling to our sampling site, we can close those ball valves, which will isolate the filter contents and minimize any type of contamination that could occur in transporting the filter. On the back end of the filter, we have our flow totalizer, which we use to measure the amount of water that we had sampled so far. And one thing I'll note here is a lot of these components did come with plastic seals and gaskets. So where possible, we did remove those, which led to some headaches in some instances, but I'll cover that a little bit later on here. So before every sample was collected, we went through our cleaning protocol to try and minimize any carryover between samples. The first step in this protocol was soaking the filter in a dilute hydrogen peroxide solution, just to loosen up any stuck-on organic matter that microplastics might have been bound up in. So we would fill the filter with the solution, let it soak for about a half hour, and just agitate it around, shaking it, inverting it, just to loosen up anything that might be stuck in the filter. And I will mention here the peroxide we used and any reagents, all the DI water, we filtered through a 1 micron glass fiber filter prior to using it, again, to just eliminate any contamination that might have been present. So after the peroxide soak, we cleaned all of the components with a natural fiber sponge and some mild detergent, and we triple rinsed them with microplastic-free DI water, again, made by filtering through a 1 micron glass fiber filter. So once we completed the cleaning, we covered any open ends with foil. As you can see in that picture there, that's the filter ready to go for a sample after it's been cleaned. And this was just to, again, prevent contamination. That was one of the big focuses of this, was as many points of contamination as possible to reduce them. And with that being said, we did perform all of the work under a laminar flow hood when possible for the contamination issue. So at the start and the end of this sampling event, we collected a field blank to try and detect any contamination or carryover that we may have been picking up throughout the process. And to collect these blanks, we had a large glass carboy that we filled with that microplastic-free filtered DI water, and we ran it through the filter unit and processed it the same way that we would a sample. Ideally, we would have filtered an amount of water that was representative of the amount that we were filtering for a sample, so around 500 liters, but it just wasn't feasible for us to produce and store that quantity of filtered DI. So we got the largest carboy that we could find for this, and it ended up being around a 20-liter sample for those field blanks. Now, as far as sample collection goes, for most of our sampling sites, we were sampling directly from a sample tap, and where possible, we had dedicated sample taps installed in a location to minimize or eliminate the upstream presence of plastic components. And in those instances, we would thoroughly flush the sample tap prior to sampling, just to get rid of any residue that might be in the tap. We assembled the filter on site, connected it directly to the sampling tap, and we would filter until we hit our target volume or until the filter clogged. And this round of sampling took place during our low flow season, so the particulate matter in our source waters was fairly low, and we were able to achieve our target volume on all of our samples, luckily. So once the samples were collected, as I mentioned those ball valves earlier, we would close the ball valves to isolate the sample, and then we would transport the filter back to the lab to process the sample. So sampling for our environmental focus upstream and downstream from the water reclamation facility discharge looked a little bit different. We didn't have a sample tap to connect in those instances, so we needed to sample directly from the river. So what we decided to do for that was we purchased a battery-powered transfer pump, which was connected to the back end of the filter apparatus. That way, we didn't want to get a submersible pump because they're typically made of plastic, and that would be on the front end. So we went with the transfer pump. That way we could put it on the back end and not have to worry about that contamination. And then we submerged the inlet hose directly into the river, and we would just pull water through the filter until we hit our target volume. At these sites, we try to avoid sampling stagnant areas, and we were focusing on areas of the river that had good flow to be more representative of the water that we were putting into the river. So besides the transfer pump, sampling was largely the same as sampling from a tap, and we filtered the water until our target volume was reached, isolated the sample again, and then transported back to the lab for processing. So once we were back at the lab, the samples were processed under the laminar flow hood. The filter housing has a drain plug in the bottom of it that we would remove, drain out any of the water that was in the filter, and we captured it in a stainless steel utility tray. Then we would rinse the filter and the housing into the same utility tray using that filtered DI water, and then transfer the sample into a pre-cleaned sample bottle. The sample bottles underwent the same cleaning procedure as the filter apparatus that I had described earlier. So another thing to note is that the lids of the sample bottles were PTFE lined. So we opted to place a piece of foil between the lid and the sample, again, to just eliminate another possible source of contamination. And being that we were only working with water, there were no chemicals involved at this stage. We, again, didn't choose to wear gloves just to eliminate another source of contamination. So overall, the sampling went well, but there were a few hurdles, particularly relating to our filter unit setup that could have used some improving. Our decision to remove any plastic seals or gaskets to minimize contamination did lead to significant leaks at certain points along that filter chain. While this did cause a little bit of a mess while sampling in some of our areas, we ultimately decided that the specific connections that were leaking would not impact the quality of our sample. So we decided to move forward with the leaky connections, figuring that that was a better alternative to introducing plastic in our sampling chain and potentially contaminating our samples. So there was one instance that this actually did cause a slight issue, and that was when sampling with the transfer pump. So the transfer pump has a feature that would cause it to auto shut off if it detected that it was intaking too much air, and this was happening due to some of the imperfect seals. So in our case, there was one specific component that was exceptionally leaky, and once we removed it from the sample chain, this seemed to fix the issue. So while not a major hurdle, it is an area of our setup that could definitely use some improving on. Initially, we had worries of potential filter clogging, so we decided on the use of a pleated filter cartridge to reduce the likelihood of clogging. However, after going through this sampling, I would probably recommend the use of a smooth filter cartridge instead. The pleating made the rinsing and the cleaning of the filter a bit more complicated, having to get in all the little nooks and crannies to make sure everything was cleaned out. And overall, I think it just increased the likelihood of carryover between samples. I think it would probably be a better idea to use multiple smooth filter cartridges to size fractionate if you're worried about clogging. But yeah, the pleated filter cartridge was not fun to clean. And with that being said, this is the reason for that recommendation on the smooth cartridges. As part of our results, the lab included images of anything that was present in the sample. So on the top image there, those two images are from our initial blank before we had run any raw water or any treated water through the filter, and the bottom is our final blank. So as you can see, despite our attempts at thoroughly cleaning, there was a significant amount of carryover from previous samples, highlighting that we should probably work on cleaning protocol a little bit better, but also just the difficulty of cleaning those pleated filter cartridges. So once the samples were collected, we shipped them to EMSL for analysis. We had the opportunity to discuss our sampling plans with many great labs, but ultimately we decided that EMSL services fit our goals the best. Since we were using a 5-micron filter, we wanted to go with a lab that had a detection limit of at least that low. We found that many labs currently were offering typically down to 10 microns, so not too far off, but a little bit bigger than we were looking for, while EMSL offered a detection limit of 1 micron, which played a big factor in our decision to use them for analysis. Also, based on the information in the policy handbook, we wanted to use a lab that was using either FTIR or Raman spec to perform the analysis. And in this case, EMSL did use Raman spec for counts and polymer ID. Another reason for our decision was the cost of analysis. Being that this was just a proactive preliminary screening of our water systems, we were working within a limited budget. Many labs that we spoke to, they were charging $1,000 or more per sample, which unfortunately just wouldn't have been feasible for us at this point in time. And EMSL's costs were about half that. They were $499 for count and ID. So on to the results. Interestingly enough, all 9 of our samples came back as non-detect for microplastics. And on the slide here, I've introduced the limit of detection for each of the sample matrices that we were dealing with. Based on all of the available research regarding microplastics in environmental matrices, we found these results to be a bit puzzling. So after receiving the results, we reached out to the lab just to confirm there wasn't a mistake in the reporting. And it sounds like from their experience, they informed us that it is not uncommon for environmental samples analyzed for microplastics to come back as non-detects. So this contradicts much of the available research on the presence of microplastics in environmental matrices. Although I will say it isn't terribly out of line with the study that I mentioned earlier, specifically regarding microplastics in the Big Thompson River. But unfortunately, we're still uncertain of the accuracy of the data, and we're planning on performing more sampling just to confirm that these results are accurate. So what can we learn from this? Although the results were a bit unexpected, there's still a lot of valuable information that we could take out to prepare us for future sampling events better. I think any future sampling events, we're going to try to increase our target sample volumes just so that we could catch more microplastics, ultimately giving us better resolution and less of a likelihood of running into a situation where we are getting a non-detect. If any future sampling events do verify these results, it could indicate that inline filtration and the other measures that we took to reduce contamination throughout the sampling process were fairly successful, but we'll have to see. I would be hard-pressed to believe that I'm the first person in history who could go through microplastic sampling without getting any contamination in my samples. Another thing we learned is that we need to implement more robust QC protocols for future sampling events. As I mentioned earlier, we just wanted this round to be a high-level preliminary study to better direct our future efforts. And based on the research, we were expecting to have a fair amount of contamination in our samples. So this, combined with the fact that we were working on a limited budget, led us to decide to scale back our QC efforts until we had some more data so that we could have a more directed sampling effort. As I mentioned, for this round of sampling, we had the field blanks that we collected at the start and the end of the sampling event. And then the lab prepared and analyzed their own lab reagent blank, which consisted of particle-free filtered water, and a fortified blank, which consisted of that same filtered water that was spiked with NIST traceable polystyrene microspheres. So based on the guidance in the policy handbook, the next time we have a round of sampling, we're going to implement a fortified matrix sample just to ensure that the complex matrix of our samples is not impacting the lab's ability to accurately identify microplastics. And I'll just mention this here. I think this is something we're going to be talking about later today. But I think that this highlights the need for some type of lab certification for microplastic analysis. So it'll be exciting, the next time around that we do this sampling to hopefully be able to work with some labs that have some type of certification or accreditation when it comes to microplastic analysis. So after results like these, we're going to have to go back to the drawing board and come up with a plan forward, but we are definitely intending on performing some further, more in-depth sampling for microplastics to get a better idea of how they're impacting our system. Initially, we had planned for 2 sampling events. We were going to do one in a low flow period and one during a high flow period to see if there was any difference between the two. And that's why we have our upcoming sampling event scheduled for June. That will be our period of high flow. This previous one was in December. I don't believe I mentioned that. So that was a low flow period. But depending on the results that we get from this next round, we may end up resampling again in the winter of 2025, just to try and either verify or get better results in a period of low flow. And then, as I mentioned, as part of this next round of sampling, we're going to beef up our QC protocols, explore the what other lab options are out there, maybe switch labs or do some split sampling between labs. Hopefully try and find a lab that is willing to analyze wastewater samples. That way we can move forward with our plans to sample our water reclamation facility as well. So with all of that, thank you all for your time today. And again, thank you, Scott and Monica, for giving me the opportunity to share what we've been working on. If anyone's interested in discussing our sampling efforts in more detail, you can feel free to reach out to me. There's my email right on the slide there. And if anyone has any questions, I'd be happy to do my best to answer at this time.
Fascinating
we-
work, man. Yeah, thank you so
Okay.
much for presenting.
What's that?
Thank you so much for presenting. It's
Oh,
really
yeah.
awesome to see what you guys have been up to, and particularly impressive that you've been able to do effectively what California is trying to do well ahead of us. So we're going to be learning from your efforts, and hopefully you guys can learn from ours. Yeah, really, really impressive. I think Shelley Walder's got something already.
Yeah, go ahead, Shelley.
Thanks so much, Nick, for your presentation. That was really interesting. I have to say probably not so surprising, just because previous studies have kind of, the diel variability and the volume are both really important. I was curious, you mentioned the volume that you had, like, so some of these non-detects were 1,000 liters that had been sampled of river water?
Yes.
Okay.
So our source waters would have been 500 liters.
500 liters?
Yeah.
Okay. And did you take into account kind of diel variability, or was it just all, getting it as quickly as possible at one time?
Yeah, so that's actually not something that we had taken into account when coming up with our sampling plan. So these samples were just collected we hooked up the filtration unit, we ran it until we hit that 500 liter mark, and then we went back to the lab. So we did not take into account any variability throughout the day that could have been occurring.
From previous studies that I've been involved in at our agency, going back to like 2014, there is a lot of diel variability, not only within 24 hours, but day to day, between weekday versus weekend. seasonally, holidays, you're just going to have different inputs to, specifically for wastewater. And so when you're trying to get wastewater samples, that's really important to keep in mind with the, if you were to do something, again, with the closed system, I'm not just specifying ASTM, but one of the things ASTM, beyond the tiered, the sieves, is sampling that volume throughout the 24 hours. So it's like a gallon a minute, something like that. So maybe that's averaged over 24 hours. That's more reasonable.
Yeah, I do like that. That's not something we had given any thought to, but now that we're talking about it, I do see the value. We were mostly focused on doing it as quickly as possible just because of, staff issues and whatnot. But I do see the value in doing it, the ASTM method, and getting that whole one full day of resolution in your sample.
Right. And just a comparison, it'd be really, if you have bandwidth and people to do it, it'd be interesting. And you don't have to do it all in 24 hours. You can do 6 hours, 6 hours, 6 hours throughout, a few days to cover the whole diel variability. So it's more workable for staff.
Yeah, I like that idea. I'm definitely going to note that and take that into account next time.
I'll get in touch. Well, we can talk more.
That'd be great.
And then I was also curious about the sampling depth in the rivers specifically. Like, was it just at the surface, or did you use an integrated system? How did you do that?
So we, it wasn't standardized, but we were trying to get roughly the middle of the water column. We didn't want to do the surface just because of anything that could have blown in and been floating on the top of the water that wasn't from our water reclamation facility. And we didn't want to do the bottom just because there was going to be more sediment, which would clog the filter. So we were kind of just aiming for somewhere in the middle of the water column.
Makes sense. Yeah, so depending on the density of the particles that you were, might have found, some of them might have been lower density and they might have been floating or sinking if they're, and so there might have been missing that component. Just ideas.
Yeah, that's great. I love it. Thank you.
I'll chime in here. If anyone has questions, please raise your hand, or you can unmute and ask them, or you can stick them in the chat and we will read them. So thank you, Nick. This was wonderful. And I have a lot of questions and I might follow up over email. But one of the things we've seen is for sure pretty big changes, and, being not that far from you all in Nevada, pretty big changes with discharge changes. So I definitely think looking at the different seasonal variations would be really interesting. With our rivers out here. So that's something I think to think about. And then the big question I had though was, the big thing I've always wondered about these pleated filters is if you're actually getting everything off. Do you have thoughts on that? And how difficult was it? Is there anything that, maybe you learned from that process?
Yeah, so I don't think it is very easy to clean them off. Based on those pictures I showed from our field blank at the beginning and our field blank at the end, there was a significant increase in the amount of particulate matter that was present in our last field blank. And I do think that that was largely due to all the little nooks and crannies in the pleated filter that it's just very difficult to get to, especially, I felt like our cleaning protocol was pretty sound overall, but I just don't know how, no matter how well you clean it, how well you're really going to be able to get into every nook and cranny on those pleated filters. So I think that as I mentioned in the presentation, I think that it would be better to use multiple smooth filters to size fractionate the sample if you're worried about clogging, opposed to using one pleated filter. The benefits of the pleated filter are just having more surface area and they won't clog up as quickly. But I feel like when we're dealing With something like microplastics that are so tiny and could just get stuck in every little nook and cranny that there is, it's probably best to go with the smooth filters just to kind of eliminate another variable that you have to deal with when doing the sampling.
Yeah, thanks. I didn't actually know that they made smooth filters other than the like I guess I don't know why I can't think of the word right now, but the like the fiber ones, whatever those ones are.
Okay, yeah.
So
I think, yeah, if you want to get in touch with me, I believe the company that we used, which I don't know off the top of my head, but I could get that for you. I believe they made smooth stainless steel filters as well.
yeah, awesome. Great.
Hi, Nick. Great presentation. You have done a lot of work. Our laboratory is Metropolitan Water District of Southern California. We receive Colorado River water, and so because we're in California, we're setting up for the microplastics analysis. And currently, we're also working on sample collection and sample preparation procedures. We did use the smooth cartridge filters. Colorado River that we receive as a very high TDS content, around 600. So I had two questions. But before the questions, I just wanted to mention that having the smooth filters did not help us at all. We did have issues, and we abandoned the smooth filters because we were unable to clean them off. And so we couldn't reuse them, and we couldn't get the whole sample off. Part of that was because of the high TDS content, but also the biological material that was in the water. And so the first question I had was, what was the TDS of the water that you were processing? Did you know that?
No, so actually I don't know that off the top of my head. It was like I said, it was during a period of low flow, and our water in Loveland tends to be pretty clean during that time of year. There's not much suspended solids or dissolved solids in it. But off the top of my head, that's not a number that I have, but I could get that for you if you were interested.
Yeah, rainfall tends to be a very low TDS matrix. That would make sense. And so the second thing was, did you, other than the hydrogen peroxide, what other approaches did you use to reduce the biological content of your sample? And did you do any controls for or research on how effective the sample preparation procedure was?
So reducing the biologicals in the sample or reducing them on the filter once we were cleaning it?
Yeah, so it would be both then.
So in the sample, we didn't do anything. We just filtered the sample. Whatever went into the filter, we rinsed off as best as we could, and then directly put that into our sample bottle and sent it off. So we didn't do any type of control on biologics for the sample. As far as the cleaning goes, the peroxide, we just used the peroxide. That was the only thing aimed at biologics in particular. And then we cleaned it off with the natural fiber sponge and the soap. But no, we didn't. That wasn't something that we got too hung up on in our sample planning.
Okay, so just to be clear, you didn't do any QC on your sample preparation procedure. You have no idea what your recovery efficiency for that part of the method was, right?
For the recovery for what part of the method? For the filtering?
Sample preparation.
No, so I guess the only QCs that we did, as I mentioned, were the field blanks. So that would have been just the DI water filtered through it just to see if there was any carryover. And then the lab did QC internally to make sure that they were detecting microplastics properly. But beyond that, that was definitely an area we were lacking this time around, was our QC. So it's something we're going to be working on moving forward to improve upon.
Yeah, it's definitely an important part of it.
Mm-hmm.
Okay. I don't know.
And sorry to interrupt you. Mostly that was just because of funding. We were operating on a very limited budget, and the analysis for this is not very cheap. So unfortunately, we had to scale back on some of the QC stuff that we wanted to do just because we didn't have the funding to analyze. We would have spent all of our funding on analyzing QCs and then only had enough for 1 or 2 samples left over, unfortunately.
Okay, so just the last question. I have more questions. Again, we could take this offline.
Yeah, no problem.
And some of my coworkers here that are on the call listening in, if they have any questions, we would like to talk with you. But I am curious, and this is for the whole group. How long did it take for you to extract your sample off the filter cartridge?
So it probably went to the point where I thought I had gotten most of it off. It was probably 10 minutes or so of rinsing the cartridge. But clearly, yeah, that was not enough because there was a significant amount of carryover, even after, not only after the carryover pictures that I showed was after cleaning the cartridge. So I'm sure there was even more left on the cartridge prior to cleaning, but post rinsing that that we missed out on. So yeah, probably spent about 10 minutes or so in the cleaning of the filter cartridge per sample.
Okay. Okay, thanks, Nick.
Yeah, no problem.
There are some questions in the chat. Trying to read them. Unless was somebody trying to unmute. Sorry if talking. Just wondering, what is the acceptable flow rate range when filtering the water? Also, what is your protocol if the filter is already clogged halfway of the filtration?
So I don't have the flow rate off the top of my head. That's going to vary based on what filter that you're using. I would have to look at the specs for the filter that we had, which I don't have in front of me right now, but I can reach back out to you and get you that information. For as far as it goes, if the filter clogged during sampling, based on the scientific literature that we found, it sounds like most people were filtering in hopes of achieving their target volume. But if it clogged before they hit that target volume, then they just settled on whatever volume they reached before clogging. Like I said, fortunately, we didn't have to deal with that this time around because it was during a period of low flow where we have very low particulate matter in our water. But I think if we were to experience a clog, the procedure that we would follow would to be just ending the sample once the filter is clogged and then using that volume, that total volume for our sample analysis.
Great. I think that was it. Anyone else have any questions? Brent, do you want to follow up? Go ahead.
Oh, sorry, I just have a quick question about the analytical lab EMSL. Did they provide any positive control demonstration of their capabilities? I'm just curious, like they might have been missing actual microplastics in the sample if they were using like LDIR, which has like a fairly low or had fairly high false negative rate. I'm just trying to figure out like why they didn't find a single particle in source water with a 1 micron detection and high sample volume. Like that is actually really surprising to me.
Yeah, I am not sure. So the method they're using, like I said, was the Raman spec. And then they analyzed an internally spiked blank, which they did recover. I think let me see real quick. So they recovered 99.5% of their spike in their internal sample. But I don't know if the complexity of our matrix could have been interfering with their ability to recover it. You know, they were using very clean water with very neat spherical polystyrene spheres in there. So I don't know once you throw all of the gunk in there. Oop, I'm sharing by accident. Once you throw all the gunk in there that's in our water And then, you have more irregular shaped microplastics if they had a harder time detecting those. But yeah, it's definitely something that we were very confused about as well once we got those results. That was not what we were expecting at all.
Do you happen to have any other samples that haven't been processed yet?
No, not from that sample period, unfortunately not.
Or like the filters, if you still have the particles on filters, or
So the filter, it was just one filter that we reused for the samples, and it's been cleaned since then. So no way to go back to these samples, unfortunately. But
well,
as I said, I think moving forward, I think if we do decide to use EMSL again, which I'm not totally sure that we will, I'm planning on doing some more research on labs. It's been, just about a year and a half since we first took on this project. So I feel like a lot has changed in that time. So maybe there's some more labs that can do the analysis in the price range that we're looking at. But if we do decide to go with EMSL again, I do think that we are going to at least do one split sample with another lab. That way we can verify that their results are accurate.
Yeah, absolutely. And just for everyone's awareness, there are now 2 laboratories that have ELAP accreditation in the state of California. McCampbell Lab and the Moore Institute for Plastic Pollution Research.
Yeah, that's great to know. I think when we first started this, I think you guys were just starting that process up, and no one had gotten that claim to fame yet. So,
Yeah, I think what you just said about splitting samples is a really important aspect of moving forward with standardizing the protocols. But in my opinion, this protocol should start at sample collection. And that sample collection, sample preparation, and sample analysis, just like it is for Cryptosporidium and Giardia, is all one method. And so that we could have the same exact standard operating procedure validated from more than one laboratory, as many as possible, if in fact the health effects information demonstrates that this is a concern for public health and drinking water. So I feel like a method validation study, like a proper round robin, would be really useful.
Any other questions? Right. Well, thank you, Nick, so much.
yeah, thank you guys for letting me share.
If you want to drop your email in the chat as well, because I see that there's some other discussions, that'd be great. Do we still want to take a 5-minute break?
Yeah, I think that'd be good.
Okay.
Chat a little bit.
Great. Let's take a 5-minute break. And so we'll be back at, I guess, noon. And then we'll have Valerie next. Thank you.
Thank you.
Yeah.
Appreciate it.
Yeah.
Although-
You even got grilled and you did really good.
I did okay.
All right, how we doing? Valerie, are you here?
Yep, I'm here.
Excellent. Scott, would you like to introduce Valerie?
Absolutely. Alrighty, so next up we have Dr. Valerie Hanley. Dr. Valerie Hanley works for the Department of Toxic Substances Control, which is an agency as part of the California Environmental Protection Agency that has been working recently on microplastics with their Safer Consumer Products program, placing microplastics on the candidate chemical list. And Dr. Hanley is one of the co-leads for the Interstate Technology Regulatory Council, or ITRC, microplastics work group. I believe they've been going for, 3 years now? They put out a number of documents on emerging contaminants. They did a fantastic one for PFAS, and it's kind of an updating thing. They have a really cool website, lots of synthesized information. So this is a product for really anyone, but specifically aimed towards risk managers, the environmental monitoring community in the States and worldwide. So I'll pass it over to Dr. Hanley. Thank you so much for presenting today.
Thanks, Scott. Thanks, everyone, for having me. And I recognize that I'm not in presenter mode, but that's because I'm going to jump back and forth between our website and my slides, because what better way to talk to you about the toolkit than to actually show you the toolkit instead of just putting them in slides. So that's my plan here. But yeah, as Scott said, so I'm a senior toxicologist with the Department of Toxic Substances Control. And I've worked with ITRC, gosh, going on 10 or 11 years on various topics. So for those of you who are not familiar with ITRC, it's a state-led coalition that has folks from state, federal, stakeholders, people who are just basically interested in environmental issues, to tribal stakeholders, to retirees, to all kinds of things fit in that stakeholder category, and then industry members. And that's a big way about how the work is funded, is that if you are, part of, if you're in industry and you work for a company, then those companies have to pay dues. Otherwise, it is free for state employees to be part of ITRC. Let's see, are you guys seeing my screen and not me? Because I'm seeing myself giant on my screen, and that is annoying. So can someone confirm?
Right now I see the PowerPoint sort of screen.
Excellent.
Yeah, not you.
Okay, good. Then I'm going to minimize that screen so that I don't see myself. Okay, thank you. Anyways, it's funded through both the industry member fees and then also through federal grants. It does operate through ECOS, the Environmental Council of States. And the whole purpose of ITRC is to develop guidance documents and training using a consensus-driven process. Historically, ITRC has focused on, typical environmental remediation type topics, and it's really only been in the last 5 or 6 years that they've started to get into some of these more emerging topics. So as Scott mentioned, the PFAS team was really the first one to kick it off. There's a excellent and always evolving PFAS guidance document. In fact, right now I'm helping a little bit, and so is Scott, with the microplastics and PFAS priority topic, as they call it. So they're in a chapter right now in terms of connecting microplastics and PFAS. And then Microplastics got funded for our project first to do a technical guidance document. So that was the first phase of our work. And then since then, there's also been the Contaminants of Emerging Concern team that is now in their second phase. So in our first phase, I was co-led by Kim Nemmer, who's in North Carolina. And we developed the technical guidance document, and I'll take you through that just a little tiny bit, but I understand that this is a group that very much knows what microplastics are and why they're important and why we need to look at them. So kind of the typical slides I would give don't really fit as well. But I'm going to share with you our technical guidance and how you can access that. And then we'll talk some about our outreach toolkit, which was the second phase. And that was led with Grace Ann Martin from the not Southern California, but that's what I think of when I see SC, right? Sorry, South Carolina Department of Health and Environmental Control. Although they just changed their name, and I think that's their old name. But anyways, that's the ITRC microplastics team. We started the technical guidance in, I think it was November of 2020. We started working on it. The technical guidance went live in early 2022, and the outreach toolkit went live earlier this year. So all of our, let me make this a little bit smaller so you can see the whole slide. So all of ITRC's guidance documents are web-based documents. So we don't have like a printed manual that you get to have the document, because most people, read stuff online now, although there are options to print out if, you want to go with that route. But that is the, up here I have the URL to our guidance document, and I will stick that in the chat later too. But you can see it's an online document, and then we also offer trainings. In fact, our most recent training was just last week. It's about a 2-hour training that goes through all the topics that we cover in the technical guidance document. Probably information that most of you all in this subcommittee are very familiar with. Yeah, all of those trainings are archived on the Clue-In website. So you can go to that link that's down at the bottom of this presentation of this slide, and that would take you to where our archived trainings are if you're interested in listening to that 2-hour presentation. We cover everything from just an introduction as to what microplastics are, the definition of them, why they're important, and then we have a section on environmental distribution, fate, and transport. We talk about sampling and analysis, all those special considerations like you all have been talking about in terms of the care that needs to be taken in sampling and lab setup and preventing cross-contamination and all of those things. We have a section on human health and ecological risk effects. And then we have a section on regulatory context where we've just gone through and kind of gathered all of the related different regulations that exist, from single-use bag bans all the way through microbead bans and the work that's been done in California the last 6 years or so with those 2 Senate bills that have driven all the microplastics work here in California. And then we have a section on mitigation and abatement, and then we go through data gaps and future research needs. And you'll see that we also have a tab on there for our microplastics toolkit, which was added recently. So this is just to give you an idea. This is kind of how our technical guidance document works in terms of navigation. And rather than show you this slide, I am going to show you the website itself. So this is the website. So if you went to, I'm actually going to go to environmental distribution, fate, and transport section. And when you go to that section, you actually will see the same figure I was just showing, which this is our conceptual site model. And now each of these red dots, if you were to click on them, they would bring up this section that talks about that particular biota or area that matches that in our guidance document. So you could then click on it and it would take you to the different appropriate sections. So this is our guidance document. It has everything. You can navigate it either through the side over here or using the navigation to go within the different documents. But then what I really am here today to talk to you about is our outreach toolkit. And so this was released, like I said, earlier this year. And it was really designed to give information on outreach, to provide information for folks like those of us on this call to communicate with others about microplastics. We have 3 main audiences that we focused on in this guidance document. We have our general audiences. So really, this is information that can be used for anyone. And then we have our scientists and regulators. So that's kind of more for us. And I'll talk a little bit more about what's in each of these sections. And then we also have a section that's on decision makers. And so this is really how people can, particularly those of us in state government, but also elsewhere, can go to lawmakers and talk to them about the importance of microplastics, give some tips on how to do that. We have a presentation in there, some elevator speeches. So maybe within your department or within your local government, there's ways that you can communicate with people who are decision makers to help increase awareness about microplastics and why we need to move forward and work on not only analyzing them, but really taking a precautionary approach to handling microplastics. So let's see, I'm gonna skip back and forth a little bit. So we also have a section on how to do outreach yourself. So maybe we don't have a fact sheet in our guidance document that is exactly what you're looking for, but you want information on outreach in general. And so we do have an entire section on best practices for outreach, for developing messaging. We talk about different types of outreach, from fact sheets to slide presentations, posters, as I mentioned, elevator speeches. We have a whole section on tips for social media with a little blurb about all the different social media outlets and what they might be useful for. So I just thought that could be useful to know in case you were interested in developing some outreach yourself, because you didn't find a fact sheet that exactly fit the bill of what you might be looking at communicating. We have that information there as well. Let's see. So some examples from our outreach toolkit. These are different fact sheets for our general audiences. So we have a microplastics, the basics and what you need to know fact sheet. We have one about sources of microplastics, one on what individuals can do to help reduce microplastics. And then we have a really neat resources for educators. So this is for teachers who want to, specifically K through 12, but that want to bring microplastics into the classroom and teach about them. And we have a spreadsheet on our website there where we've gathered a lot of educational resources. There's various activities you can do, and we have that sorted by age group and what kind of information is in there. So if teachers wanted to bring microplastics into their classrooms, they could use that. I actually want to say that I've been really happy that my senior in high school came home last year and told me he was doing something on microplastics. I was like, oh, did you think about talking to me first? He's like, why would I talk to you? Anyways, teenagers are fun. And then these are a little bit more graphical fact sheets with less words, because we know people learn in different ways, right? So we want to make sure that we can provide information in different ways. And in fact, on our website, we have a table with all of the different materials, and in some of them we have suggestions where maybe one of these could be, maybe this sources of microplastics graphic would fit well with the text one on the back. So if you were doing a front and back side, you could do that. And so we have those kinds of recommendations within the toolkit itself. And so these graphical ones are very similar to the text ones. Like I said, just provide a little bit more, a little simpler way for people to grab it. These also would work nicely as being printed as posters. If people wanted to print them larger and put them in different places for informational reasons, I think that they serve themselves really well for that as well. For our scientific folks, We have a fact sheet on microplastic sampling and analysis. We do have a sampling tool that is part of our regular guidance document to help you decide if you're going to go out and sample, what things you would want to consider. And it links to a lot of the primary research that's out there. We have a section on the importance of comparable units, so that we can compare across different publications and tried to really have that information to help, develop our TOX criteria or risk-based values moving forward. Scott's done a lot of work on that, but we don't have, a single, we're not quite there yet in having those regulatory numbers, but the more we can have people presenting their data in the same units, the easier it is to cross-reference between different studies. We have a section on, health effects and what we know now. We have a section on data gaps, so some recommendations for folks who are going to be doing microplastics research, and where what we see as data gaps that need to be filled right now. And those are focused on the different main topics of the technical guidance document. So we have something about fate and transport. We have one on sampling analysis. We have data gaps on, health effects, mitigation, abatement, et cetera. And then we also have a fact sheet that's just on the different types of microplastics, right? That primary versus secondary, and what their sources are. So it's a little bit more detailed than the sources one that's for the general audience, because, right, we're taking our audience into consideration when we develop these different fact sheets. So this one's a little bit more technical in nature versus the other one was a lot more general for the general audiences. For decision makers, we have, this is a brief that is a focus sheet that is working with decision makers. So this really goes through the types of information you want to share, how it needs to be concise, how you need to really hone in on your messages. We have specific recommendations for working with lawmakers, but then we also have a section in there for companies. So if you're within a company and you really want to get your CEO on board or someone else on board to have you continue to look at microplastics, then we've got things for the private sector as well as the public sector. We also have a microplastics presentation. So this is a PowerPoint presentation. It's available in both PowerPoint and PDF, so you can download it. So if you're, and I think it's meant to be about a 10-minute presentation. So if you're invited somewhere and you want to give a talk on microplastics and you don't want to have to, reinvent the wheel, or you were looking for something quickly that you can grab that. You're welcome to use as few or as many of the slides that are in that slide deck as you would want to. We do just ask that, you acknowledge ITRC and our work when you're giving the presentation. But otherwise, that is available to download and use. So that, I think, is all I had on the outreach toolkit. But I just thought I would, just to kind of drive you around a little bit. So that was the background information on outreach. And then so for each of these different audiences, what we've done is we have the fact sheets listed individually like this. We have a little bit of information about how we developed them. Oh, we also have these different posters that were made. In fact, one of our folks, Alex McDonald, some of you may know him. He was retired from the State Water Board. He created all of these, and we have some T-shirts with this information on it. I have this. The one with the whale and the one with, I can't remember what that little tiny dwelling animal is from the, let's look, because that's what this is, right? We can just look at it. So Euryanthes plasticus. This is actually a very creature from the Marianas Trench, 7,000 meters underwater, right? Because we know we see microplastics even that far down. So those end up making great posters, but also great T-shirts. I'll actually show you a picture in a minute of some of us in those pictures. But we also just have more examples about how to create key messages. We have some example social media posts. If you were going to be, doing a project or you wanted to have a campaign where you were texting out something every day about microplastics, we have some suggestions. We also talk about image sizes for different media posts. And so we have this one particular image available in all the different ones, but we also do talk about what the pixels are and the aspect ratio for you to consider if you are developing your own materials and you want to think about the size of your images. And then, so yeah, scientists and regulators. Similarly, we have our fact sheets, and we also have a poster. This poster is really a poster that we created to introduce the ITRC microplastics guidance. So I'm not really sure who else outside of ITRC would want to be, presenting this, but it is available in PDF and PowerPoint if anybody was interested in downloading it. It is a great way to, make it known to folks that we have this guidance document and it's available. And, if there was anything you wanted to grab off of there, again, you would be able to do that. And then the decision makers, this is the wonkiest part for me, is you have to click the section you want to go to twice. But then again, we have these fact sheets for the decision makers. We have another What Are Microplastics? It's written at a slightly different level than the one that's in the general audiences. And then we have this work decision makers focus sheet to really help out, and we have that presentation here, and we have a few elevator speeches, and then just tips for communicating with legislatures, how you strategize a campaign, meeting with them, providing handouts. We worked with someone. I know his name was Hunt. Anyways, he works on Hunt Vandertol. He is a friend of Grace Ann Martin's, who was my co-lead for the outreach toolkit. And he gave us a lot of insider information about how the legislative works. So that was really helpful. And then at the end, I just wanted to point out, we do have this index of all of our materials. So if you just wanted to get an idea of what you're looking for, you could come to this and just look through the various things. And again, this is that K through 12 resource list. Oh, I guess it's just going to bring up an Excel. I won't open it, but it's just an Excel document that goes through different materials for the K through 12 teachers could use. I did just want to highlight current ITRC projects. So I mentioned the contaminants of emerging concern. They are currently in their second phase. They already put out a document on contaminants of emerging concern, but they couldn't quite get to the biologicals. And so they're doing that right now, although I think they are pretty close to wrapping that one up as well. And as I mentioned before, PFAS, just like it's a forever chemical, it's the forever team for ITRC. And so really it's just, they're constantly updating that guidance document, and we hope that we continue to learn as much about microplastics, that we will have another phase of our microplastics team so that we can update the materials we have now. Since we know how much research is just ongoing at such an exponential pace, that we really are going to want to update that once we have additional information. And then there's also the vapor intrusion and evaluation team that's ongoing. These are the new teams that are coming up in 2025. So our green and sustainable chemistry, sustainable management from waste and energy sources, underwater munitions response technologies, and then there's an advanced site characterization tool that's already part of ITRC, and they're updating that for current information. And then this is just this is the team that met in San Diego, although Brett was there, and this was the second day though, so I don't think we have a picture of him in his t-shirt, but anyways, this were the t-shirts that Alex made for us. Anyways, that microplastics are in creatures great and small. This is the whale, and it has a little tiny shrimp by there, or maybe it's a seahorse that's on there. They're great shirts. Whenever I wear them, people always just look at me and say, that's really depressing. And I said, yeah, well, it is, but you have to raise awareness. So Anyways, that's all I had to present today. So I just really kind of wanted to go through what the outreach toolkit is, and I'm happy to answer any questions if anyone has them, but really it's just a great idea to go on and explore those materials and see if there's something in there that will work for you in terms of doing outreach.
Excellent. Thank you so much for that wonderful overview. Are there any questions? Please unmute or put them in the chat while people are thinking. One question that came up in the chat is the educational material provided in Spanish?
I think some of those might be in Spanish. It's a great question, but I don't know that many of them are. They weren't anything that we created ourselves. We link to them. And I have to say, I have not personally looked at every single thing that we link in that. So I would certainly hope that some of them are in Spanish, but I don't know. I can look into that and get back to you.
Excellent. I had a question. My question was about the process for making this all these guidance documents. In particular, I was thinking about some of the outreach materials for teachers. I was curious if, you mentioned kind of having a stakeholder team. Are there like teachers or policymakers involved in that stakeholder team? And are they sort of vetting these things and sort of saying like, yes, this is helpful. This, in the teaching world, we often think about the what standards these materials are meeting. Have you had those types of conversations as part of this?
Yeah, so we originally developed the K through 12 fact sheet because we had someone who was on our team who was a retired teacher. And so it was his idea. And we really liked the idea. So one of the things is ITRC does not endorse anything in particular, right? And so I think we do have a disclaimer that we recommend you look into it and make sure that it fits well with your school requirements and all of that. So while they have been looked at, they are all just publicly available things that we really just wanted to give folks resources that they could look at. We did go through, people on our team went through every single resource to evaluate it. There were some that were eliminated because we didn't think it fit well, or we didn't necessarily agree with what was in there. So there certainly was a QA/QC. The other thing I'll say for our guidance document, so our technical guidance document, we had a team of 400 and some folks from states all over. So when we first start a project, we send out a state survey. And this goes out to the states and we ask, like, what do you already know? What do you need? What's important? All of these things. And then we kind of use that information to help us in developing what we're doing. And so that's actually in that regulatory context section. We have the survey results too from that original time. And then we have folks from all over. Sometimes we do have to spend time recruiting more people that have knowledge in microplastics because, our general ITRC, the people that have been in it for a long time really deal a lot with remediation and kind of our typical things. And so it's very outside the realm. I will tell you, I leaned on Scott a lot. I called Scott a lot, or I texted him. I emailed him a lot. I'm not a big phone person, but anyways, I emailed him a lot and asked a lot of questions. And so he was really helpful. And as we're developing things, we do send things out for external review. And so during that time, again, we go out to our networks at all the states and we ask folks to review it. We have our our federal partners, including DOE, EPA, go through and vet all of it as well that way. And then, we take all of those comments and we respond to every single one of them and address all of those comments. Moving through, so that's part of the way that we vet the process. And Scott's just been so helpful, and he was able to go with ITRC to Australia to help present on our technical guidance document. Sadly, the state didn't let me go, but that's another story. And so anyways, yeah, that's been great. And Scott was also there for our kickoff for the toolkit when we were in Boston, to help us kind of think about, what are the main things we really want to get across in outreach? What's important? How do we communicate that? And as any of you who've worked with Scott for a long time, he is an encyclopedia of information when it comes to microplastics, especially. I'm sure other topics as well. But it was just so helpful to have him in the room and helping us kind of guide us in the right direction as we were kicking this off.
You're making me blush over here, Valerie.
Excellent. Any other questions? Great. I think, Valerie, if you don't mind putting your email in the chat, there's been a request, but love that anyways. Anything else before we move on to our next speaker? Our next speaker is Shelley Moore from the Moore Institute for Plastic Pollution Research.
Hi, everyone. Let me see if I can open. Oh, it's making me do permissions. Sorry. Because I don't ever use Teams. Oh, it actually wants me to quit and reopen. So I'm gonna do that real quick.
No worries. Figure it out. This is our first time using Teams, so I'm impressed with how smooth it's gone so far. Excellent. So Valerie's email is in the chat, and then also the link to the website, which is awesome.
Yeah, I encourage everyone to open it and bookmark it. Check it out. We have a minute or two before Shelley comes back in.
Yeah, and I was also exploring the website, and I saw that you all have also stuff on 6PPD and 6PPDQ, which is also, not microplastics, but really related to it. So I was already exploring that too.
Yes, absolutely. Yeah, there's been just so many great teams recently. Honestly, all led by folks in California, with our partners in other states. But we had someone from our DTSC Safer Consumer Products Program who led the 6PPD team. And then the CEC is also led by Vivek Mithrani, who is a toxicologist at DTSC as well. So, yep.
Hey, I'm back. Thanks everyone for your patience. Let me see if I can share now.
Great.
Yeah. All right. Everybody see my slides?
Looking great.
All right. So this is meant to be a really small snapshot of accreditation and what it's like to become accredited, particularly if you're a lab that has never been accredited for anything else ever before. We've got a lot of labs that are out there who they mostly do accreditation around different types of analysis, and they've got a ton of experience. They know what to expect. This is from a lab, the Moore Institute, that does not know or did not know going in what was going to be expected from accreditation. So let me give you a little bit of background before we get started. Accreditation was basically, it came out of Senate Bill 1422, which basically said that municipalities need to test drinking water for microplastics. And there needed to be a whole bunch of things done: definition of microplastics, developing a standardized method, and that method has been developed through an intercalibration study. That intercalibration study looked at a whole bunch of different matrices, and out of this study came the method for drinking water. Drinking water in particular, it was published in 2021 and has been revised, will likely be revised, I think, some more. And again, it's only for drinking water. There's two methods, the Raman and IR. And so a lot of work went into creating that. There's the big difference is how small you can look at particles as far as what their sizes are, and basically there's only been two labs that have been basically accredited so far, and I'll talk a little bit about that. Let me go over a little bit of method summary. The methods are pretty similar for both IR and Raman. You fractionate the sample based on sizes. You process the sample either through visual microscopy using a stereo microscope, and you count and basically look at color and other things, other characteristics of the particles, and then you place them either on the IR or the Raman to get the material type, what the particle is made out of. Okay. So there are two accredited labs. These are them, McCampbell Analytical. They are basically a lab that processes many different types of samples. They have a lot of experience with accreditation. And then us, we became accredited as of September 1st, 2024. And we're in Southern California, McCampbell's in Central California, and we both do the same method. Okay. How did we go through the process of accreditation? Well, it seemed like a big mystery to me when I was starting to look into it. But essentially what happened was when those accreditors, the third-party accreditors were getting trained to do the assessments, they actually visited our lab. So we knew some of the third-party assessors. So one of the first things we did was reach out to one of them, and we hired them as a consultant. And that proved to be very invaluable. We had her basically review some of our documentation. She gave us lots of great information, and then we also reached out to an accredited lab local to Long Beach and asked if we could visit them. And the woman who owned the lab and spoke to us was great. And she was very helpful, willing to share her knowledge, take time out of her day, her busy day. They were processing a lot of samples when we went in, and really helped us get an idea of what to expect during the accreditation process. We also asked tons of questions to all kinds of people that we met to get an idea of what was going to be involved with this process. Again, I'm just giving you a very high level description of what we went through. When we first thought about getting accredited, we thought it was going to be about the method, but it's actually not all about the method. It's more about the documentation of the method. So we had to come up with a whole bunch of documentation. The first thing that we did was we wrote a quality manual, and we were very fortunate. We had some guidance with that from our consultants. We also were able to get a template for that document. It's, I think, 80 pages long for us, and it's got a ton of information in it. It's basically how we are going to process all the samples, what documentation we're going to do, and specifically what we're going to do in certain cases. It's a very comprehensive document. You can also find some online, so we found some examples and used those as well. We also had to develop some SOPs, and I'll show you in a minute. We discovered that if the method for microplastics is not does not include a specific method as far as digestion or density separation, for example, we still need to include that as part of our SOP, our list of SOPs. We had to develop a laboratory information management system. That was challenging as well. We have one in place, and it is basically responsible for documenting every aspect of what we do in the lab, when things need to be calibrated, what samples are being worked up in the lab. It basically traces every piece of equipment, every thing that we buy to use in the lab, as well as every sample that comes through the lab in great detail. And then we have to do some reporting. We have to write up summaries of how things are going, what things we need to work on, and other things. So lots of documentation is involved with the accreditation process. When we were doing the assessment, we basically did all of the documentation first, and then we hired a third-party assessor. That third-party assessor was somebody that wasn't our consultant. And I think there's three companies that do third-party assessments for microplastics right now. So we contacted one of the other companies, set up a visit. We basically had everybody in our lab ready to answer any questions when they visited. And basically they sat and grilled us for about 2 days, maybe a little bit less. But they asked us to provide documentation on all kinds of different things, from initial calibration on equipment that we had purchased to where we wrote down certain values and kept track of certain information. And what they were looking for was to identify some deficiencies in our lab. Once the deficiencies are identified, they send a report to us with those deficiencies, and then they give us a month to respond. Everything has a month to respond. So if you're going back and forth on some of your deficiencies, it can be a very time-consuming process. My goal was to respond to anything as quickly as possible, so that put it back in their court to respond to us. After we responded to all our deficiencies and they were happy with those responses, we turned our application in to ELAP, and ELAP actually, because this was a new method, also visited our lab and went and asked us questions similar to our third-party assessor. They did that to both labs to make sure that as a new method, that everything was being looked at properly, and I would identify any deficiencies as well. And they actually did find a few more things. Let me give you an example of one of our deficiencies. I mentioned already that in the method for the State Water Board, there currently is not any description of how to do any digestion or density separation. This one was identified that we had an SOP, but it wasn't official, it wasn't approved by us, it was still in draft form, and that we needed to make sure that we actually went through and wrote that SOP, even though it wasn't part of the original method that that we were being accredited for. So we did that, and we basically were checked off on this as one of our deficiencies. There were some other things that came up. We took care of those as well. And it's a process where you are required to not only respond to them, but also come up with a plan of action. They want you to be very specific about how you're going to take care of correcting this this deficiency. So we came up with a detailed list of steps that we were going to do, including finish up writing the document, but also an approval process as well. Who was going to approve the document, how long it was going to take us, and other information as well. The more specific information you give, the better. And lo and behold, we responded to all of our deficiencies. And again, we were accredited as of September 1st, 2024. And I would stop there and leave it there, but I want to keep talking just a little bit to let you know that there are still some things that need to be looked at. And I know there are people looking at these things, but let's talk about kind of what the reality is when it comes to the different labs that are being accredited, I should say. We follow the methods in the document as closely as we can, recognizing that the method that was published by the State Water Board does have some places where labs can actually do their own thing, within reason, of course. So we, for instance, don't use the 212 micron filter when we're analyzing drinking water. We basically do everything greater than 500 microns visually. Anything less than 500, we do basically on the IR. And there's a ton of other things that we do that we know is not in the method. We've documented it, and we know that because we're doing those things and they're not in the document, we know that we're doing things slightly different from that the other accredited laboratory. So we've got some automation that we've put into place that helps us in doing the analysis faster, trying to keep costs down, those kinds of things. And we know that they don't have access to those same tools that we're using because we've made those tools ourselves. Some of the gaps that we've identified, and the State Water Board is aware of these, and others are aware of these. There is no standard for a laboratory fortified blank. We create our own, which I'm sure is different from the other laboratory and what they use. Again, we would prefer to have a digestion method that is standardized. Same with density separation, and there are folks working on that right now. There's no control on reference libraries. If you're typically developing your own reference library on your machine, and it would be best to have some sort of control on that. Fibers are problematic for us, and we're working through methods on analyzing fibers right now. And we need some guidance on subsampling. You can take a subsample of a sample, and that there's verbiage in the method for that, but there's no standardized method for taking that subsample. Some other gaps, we've already talked a little bit about that. We had a great presentation by Nick talking about sample collection. There's no standardized sample collection methods in place right now. And guidance for how to transport the sample to the lab. We had a lab send us, or I had some people send us some samples, and they had 16 bottles in the container, and 4 of those bottles broke because they were glass. So better ways of sending the sample, and that information are needed as well. And we need some tools. Part of what we've talked about with the microplastics monitoring playbook, one of the subgroups for the microplastics subcommittee, is the need for some tools that look at sample design, the potential for leveraging samples so that you don't take and pay for more samples than what you need. There's other people collecting samples in your region. Why not use some of their data? Data analysis tools, data interpretation tools, all are needed. And I'll stop there and ask if there's any questions.
Thanks, Shelley. It's really great to hear from a lab that's been through this process. Any questions? I will say I particularly appreciate, your perspective as a lab that, like you said, doesn't have all of these other accreditations. Yeah, Shelley, go ahead.
Thank you. Great presentation, Shelley. I really found this valuable, especially what you did differently and the gaps, and you kind of had to do things differently because maybe they didn't exist. Did you have to, as part of the ELAB certification, did you have to provide rationale for the changes that you made, or was it just like, how did that work?
We did explain some of the changes that we made, but mostly that was part of the process of ELAB coming to visit our lab and basically them asking us questions. So we as long as we had good reasons for what we were doing and could show that the measurements that we needed to take, the QA/QC stuff we needed to take, were still in place, we were pretty much good to go.
Great. And my other question is, I looked online, this summer for information about, ELAB certification, just to see what I could find online, and specific to microplastics. And it was like, I couldn't find much at all besides just the ELAB. There is a group called, and so I was wondering, is there some part of the process where some of this becomes public information or the guidance? How does that work? I mean, maybe you can't speak for ELAB, but do you have any information on that?
Yeah, it was super hard to find information as far as what specific steps we were supposed to take. I had actually started filling out the application, and then there was some wording in there, and I was like, well, maybe we're not supposed to fill it out yet. Maybe we should have contacted the third-party assessor first. And so I started asking questions and calling people and talking to people, and sure enough, that's what you're supposed to do. So there isn't like a step-by-step, this is how you become accredited, that I've been able to find. And so it made it a little more difficult. But there are plenty of people out there who are accredited, willing to share their information. Like I said, the lab here in Long Beach is a very small lab, and we kind of cold called her and asked her if we could come by and visit, and she gave us a lot of really good information, and that was very helpful.
Great, thanks.
Terry.
Shelley, oh
Hi.
man, I feel your pain. Oh man, we just finished a laboratory audit 2 weeks ago. We have about 400 different methods here at our water quality laboratory. We have 6 different labs, 5 small labs, 1 at each of the treatment plants and our main water quality lab. And we have been accredited by ELAP for, oh gosh, probably as since it was created, since ELAP was created. And so under the transition, trying to incorporate the new, more stringent standards, for you to jump in and start under TNI with microplastics, I can't even imagine. So anyway, yeah, and to set up a new LIMS, I just want to give double thumbs up for you guys. Wow, that's blowing my mind. What I know you went through. I completely feel the pain. So congratulations are definitely in order. It is not easy, and there are, you know, I think as you get your recurring every 2 years, you get audited, there'll be more stuff. Yeah, just to warn you. But I did have a question, how they handled the standards. And so, and what your resolution was with them in terms of validating your recovery efficiencies and reproducibility for the method. And maybe that's a long answer that we might take offline, but that's really a big problem with not having standards.
Yeah, happy to talk to you about that offline as well. We basically developed our own standards here in the lab, as far as we've got the polymer kit from Hawaii Pacific University. So we use some things out of that kit. And then we use a few other things that we have, because you have to have the 3 different size classes. And so you have to provide basically standards for each size class within the sample. So we basically use that, and we've got a method for doing that. As far as reproducibility, we did find we have to take multiple measures in the lab when we have people looking at the samples. And then as far as the FTIR, we basically just run the sample twice, and maybe turn it when we do that, to see if the numbers come up and are relatively close. So those are some of the things that we do. But it sure would be nice to be given something that we can use, that everybody uses, because I don't know what McCampbell's using. They could be using something completely different. And if we want to make sure that we're all doing very similar things, we should have some of those other tools in place.
Okay, so one more question on initial demonstration of capability. The IDCs, you have to run 7 replicate samples. So you took each of those size fractions 7 replicate times, or did you do 7 replicate samples for each of this with each of the 3 size fractions in it?
I believe we did 7 with each of the 3 size class in it, and ran it through. Yeah.
And do you use fluorescent microscopy to do your confirmation for your fortified spikes? Like, so for your for your
The larger pieces?
no, because we can see that there's a problem distinguishing naturally whatever might be in the sample from our spikes. We want to go ahead and use fluorescent spikes using fluorescent microscopy to distinguish what we spiked in there from everything else. And so that we could get the recovery efficiency for the method, and then so if it's only 5%, we know that we potentially only collect we're able to recover 5% of what was actually in the sample. So we want to have some traceability in that aspect. So do you use fluorescent microscopy in that way, or were you considering it?
We did not, and we haven't really considered it. We do mostly visual microscopy for all of that. And we also have a plate reader now, an IR with a plate reader, so we can actually fill a 96 well plate and do IR on particles as well, individual particles.
Oh, are you doing like an MPN then?
I'm not familiar with what that is.
Okay, yeah, all right. Well, there's a way to do it where it's a statistical calculation, so you don't have to look at the entire sample. You just pick a portion of it, and then that is you calculate the probable number of your whole sample.
Sure.
Yeah,
Sure.
and that's what you could use for dilutions and so forth.
Gotcha. How many particles are you putting in for each size class for your?
We haven't gotten there that far yet. We're
Okay.
working on it. we're still working on sample prep. We just so and we don't have the microscope yet, but that's why I'm asking all these questions. If it's okay, I know we're kind of close, and I didn't get a chance to come see your lab, so hopefully we'll get a chance to connect soon.
Yeah, absolutely. We'd love to have you here.
Thank you.
There is one question in the chat. It says, Shelley, how did you prepare for the LFB?
Lab fortified blank.
Okay.
Yeah. So we, just as I described, we had the different size classes, and we have different materials that we use for that. And I don't know, can't remember for sure, but I believe we only needed to have at least 10 particles for each size class. So it's nothing extraordinary as far as being able to count them and look at how much we get back. So happy to talk to anybody offline if you have questions.
You want to put your email in the chat?
Yeah.
Sweet. Shelley, did you have a question? You're muted.
Sorry, thank you. Shelley, you said something in the beginning of your talk that definitely made my ears perk up. You said that you're anticipating that there'll be changes to the state water board method. Are they to address some of the gaps that you've identified?
I'm sorry.
No, go ahead.
Yeah.
I'm just curious what those might be.
Yeah, I believe so. Those were things that ELEP mentioned to us when they were visiting, just realizing that there needed to be some more specific guidance on a few things.
And do you know a timeline?
I don't. They didn't have a timeline.
Okay, that'd be interesting to follow up on, and just all of us, the playbook, everything.
Yeah.
Thank you.
Mm-hmm.
Colleen?
Maybe I can just give some information to Shelley here about her question. So there is Scorp who is the contractor for DDW is working right now on like the digestion and sample cleaning and sample preparation part. And so the contract of that is going to be ending at the end of March 2025. And so based on the outcome of that study, that's when we're going to be able to provide some information, additional information on like what I call the intermediate steps, basically the sample cleaning and sample preparation part. Still weighing in if we're going to have all the information that we need, out of that project. But so that's why there's not much in between. We're really waiting for the outcome of that study before we can say more. hope this helps a bit.
Yeah, absolutely.
Go ahead.
Oh, I just Helene, and just in response to your the great information, can you specify the matrices that they'll be the report will cover? Is it just drinking water or source water, or what are the matrices?
So there's like 4 matrices. So they are working on sediments, which is porous media, biological tissue, fish tissue, and they are working also on natural water, basically source water. And so, and drinking water, well, that one is already in the policy handbook and the 2 methods. So that one is already covered. But there's basically the project is more encompassing, so it touches the 4 matrices.
Thank you.
All right. Well, considering that it's 1:02, if there's any announcements or anything that anyone wants to share in the last few minutes, please unmute or put it in the chat. Otherwise, let's give our speakers a round of applause and thank you all for joining us.
Thanks so much for sharing, Shelley. Thanks for everyone for coming. Again to Nick and Valerie for presenting.
Thanks, everybody.
Hey, Monica, are you still looking at my presentation or did you turn that
Nope.
off?
Nope,
Okay.
you're off.
I kept looking for a place to turn it off and I couldn't find it anywhere. I'm like, oh, maybe they already did it.